Hey folks, this is the first video that deals with applications using exponentials and logarithms. And so what we're going to do is we're going to work through a carbon-14 dating question here. Over on the right side of the screen, you'll notice that I have two equations. These are commonly used for carbon-14 dating or even bacteria growth or anything like that. But what I want you to do is just look really closely, and you'll notice that that equation, both of those equations, are essentially the same thing as what we used for compound interest when we were compounding continuously. So I just want you to understand we're really not using a new equation on this. The second thing I'd like to hand you is that for carbon-14 dating, the rate is always going to be negative natural log of 2 divided by 5,700. And in a future course, you would probably find that value on your own, but for this course, I'm just going to hand it to you. All right, so let's read the question and then we'll begin. So what we are asked to do is to estimate the age, so I'm looking for time here, estimate the age of a specimen that contains 20% of the normal amount of carbon-14 of a comparable living specimen. What you have here is you've got some kind of a specimen that has died, and as it decays, it starts to lose carbon-14. And so we're able to go backwards and estimate how old it was based on the amount of carbon-14 that was left over in it. And so what I have over on the left side of my equal sign is going to be 0.2 times p. Now, how did I get that? This, remember, is the future amount. And so this was that 20% that was left over of the carbon-14. So this is 0.2 times what I originally had. P is going to be my initial amount, my starting amount, times E raised to there's that R that I handed you, and then my T power. Now what I want to do is I want to divide on both sides by P. And so that means then that the P on the left and the P's on the right are going to cancel each other out, and I will simplify my equation. At this point then, I cannot make my bases alike, so I want to log both sides. And then I want to use my logarithm properties to simplify this. Now you'll remember from a previous session, we have something like this in one of our log properties. And so we know that natural logs and e's will undo each other. And this is going to only leave us with the power alone. We will not actually have the natural log or the e because they're undoing each other. So we've got just the power that's left over. Remind yourself that you're trying to get t by itself. And so if I'm trying to get t by itself, then I'm going to multiply by the reciprocal on both sides of the equation. Once I have this, my t is alone, which is great. But remember, I'm trying to find that time. So I want to take the left side and plug it into the calculator. And once I plug it into the calculator, I'm going to get 13,234.99. Now remember, this was my t value or my time value. And so we'll go ahead and we will simplify that to say that that was almost 13,235 years.